now it is maybe it is not possible for the time being, but maybe in February you have a time. If possible, we will show that in that time. Okay.
Yes, sir.
Yes, sir.
So I think we can start, isn't it?
Yes, sir.
19 of you is already here. So basically this is your seventh lab, and if I say, just give me a minute. Sorry for the interruption. Basically I was having some issue with, okay. Okay, can you see the screen? Can you see the screen? Yes, yes.
Yes, sir.
Okay. So basically in today's lab, we'll learn the multiplication and division. So I can say that in the last class, maybe someone from you has asked that, okay, sir, can we multiply things? Like we have learned that by shifting right and left, we can do multiplication, division, but that is by multiplication by 2 and multiplication division by 2. But in this case, we will see that there are separate multiplication division, what should I say, there multiplication and division uh, instructions which will uh, do multiplication and division in 8086. So these are the content. Basically we're going to see there are some I should say there the instructions are given here and all the things are given. So we'll go one by one. We'll see, first of all, we'll see multiplication instructions, and after that we'll see divisions, and then we'll see one one what should I say, we'll see one application like decimal input and output and why we need that thing. We'll discuss that thing at the end. So that is the total thing. Now as I'm having one problem on my Wacom, maybe I'm using only one screen, so I need someone to help me to just convert from hex to binary, and whenever I will be asking, so please try to convert that and tell me that what is the decimal and what is the signed version and unsigned version of the decimal. Okay, so uh, in the first case you can see here, Okay, first of all, we will see what is signed versus unsigned multiplication. So let us say our first byte of the multiplication, the first byte, like one number is 180. So in unsigned case, so this binary number is corresponding to 128 in decimal, and this is in corresponding to 255 in decimal in case of unsigned. And if we multiply these two, then we will get this is in uh, decimal. But if we see the case for signed one, then if we convert that, we will get minus 128, and in this case we'll get minus 1. So minus 1 and minus 128, that will give a positive value 128. So is it clear to you that signed and unsigned multiplication will give two different results?
Yes, sir.
Yes. So we have two different instructions for doing unsigned and signed multiplication. So in the first case, it is MUL, we can call it for multiply, and IMUL, then you can say integer multiply. That means it is in signed case and unsigned case. So these two are the syntax of signed and unsigned multiplication. Okay, then now how they works. So multiplication can work as byte form, or it can work as word form. So what will be the case for byte? That means we will be multiplying 8 bit and 8 bit. That means 1 byte and 1 byte. And in word form, it will be 2 byte and 2 byte. That means 16 bit and 16 bit. Is it okay? So the rule is to use this MUL, or you can say the instruction for multiplication. So if you write in this case, okay, let us say DL or BL, whatever you are writing, so it will assume that one of the, this is your source. In the last line we have said only one, we have only one operand here, so it is only the source. So this instruction will assume that another one will be at AL. Always it will be at AL for byte form. So this AL and BL will be multiplied if you're saying that this is your source. So if we write source, this source will be multiplied with
L.
AL, and then the result will be stored in AX. Is it okay?
Yes, sir.
So if it is your first byte and this is a second byte, in case of unsigned and signed, in both the cases, it will be stored in AX. But whether it will be signed or unsigned, it depends on the instruction that you are using. So that is the thing for, yes.
Since it will be stored in AX, that means AL will get overwritten, right?
Yes, AL will get overwritten.
স্যার মাল্টিপ্লিকেশনের সময় কি হচ্ছে দুইটাই বাইট হইতে হবে, আমরা কি ওয়ার্ডের মাল্টিপ্লিকেশন করতে পারবো না?
Yes, that is the word form that I was saying. That's the another slide. So here you can do the multiplication for word form. First of all, try to get this one. So for byte form, your one of the operand will be in AL, and another one will be after this instruction. That is your source. So source can be a byte register, a register, a memory byte, or anything, but it cannot be a constant. So it can be BL, DL, or anything, or any variable that A, which is a byte. These two will be multiplied, and finally the product will be saved in AX. It is very important to remember. Okay, so in case of word form, it may happen that you need to multiply two words. So what will happen in that case? In that case, the same instructions, but thing is that it depending on the source, what source that you are the source that you are using. So if that is a word, that it will assume that okay, it is a word multiplication. So it will assume that your AX will be having one of the word and another word will be the source. So whenever you will be multiplying these two, what will happen? It may need more than 16 bit. So this combination comes in this case. So the most significant bit is 16 bits are in DX and least significant 16 bit will be in AX. That means the product will be saved using these two registers of 16 bit. That means in total 32 bits. So you are multiplying AX and the source that will be saved into DX and AX. DX will be having the MSBs like most significant 16 bits and AX will have the other least significant 16 bits. Is it okay? So it cannot be a constant, but it can be register and memory word. But it is very easy to understand for positive numbers if MSB of the source and AX are 0. So these two instruction, multiplication and integer multiply, these two will give the same result, isn't it?
Yes, sir.
Yes. Have you got up to this? Is it understood?
Yes, sir.
Okay. So now the effect of these two instruction on status flag. So here these flags are undefined, so only these two, and carry flag and overflow flag. These two flags will be okay, okay. So these two flags will be updated. So how will they update? How will they update? Okay. So after, sorry. So after this instruction, if the upper half of the result is 0, then it will be 0, and otherwise it will be 1. Okay. For integer multiply, if the upper half of the result is sign extension of the lower half, then it will be 0, otherwise it will be 1. So we'll do maybe 4 or 5 examples after this, but try to get this one. So what does this CF OF is equal to 1 implies? It means, okay, just can you tell me where the product will be saved in this case?
So
Huh?
AX, so the lower half AX.
No. Not the lower half, AX. The product will be saved in AX. In this case, it will be DX and AX. Try to okay. So, and this is for word. I am saying this is for basically byte, and this is for word, isn't it? So in case of byte, so what is the lower half of AX? That means AL and AH. So if the upper half of the result is 0, that means if AH is 0, then it will be 0. These two flags will be 0. And otherwise, that means if AH is having something, some other value other than 0, then it will be 1. What does that mean? Try to get. We are discussing, I'm just giving you the example again. In case of byte multiplication. So where the result will be saved? In AX. So AX is composed of AH and AL. So it is the upper half, it is the lower half. So it is saying if the upper half is 0, if this is 0, that means 0, 0, let us say FF. If the upper half is 0, that means the lower half is enough, sufficient to hold the result, isn't it?
Yes, sir.
Yes. That means if we have any other value, let us say 0, 1 FF, it is other than 0, that means your lower half AL is not sufficient to hold the result. That means it is too big to fit in the lower half of the destination. So whenever this is not 0, your CF and OF will be 1. This is the case. Try to get. And what will happen in case of word? So DX and AX. So what is the lower half? It is AX. So if even if it is FF and this is 0 0 0 0, in this case it will be what? Your CF and OF will be 0. But if it is 0 0 0 1 and FFFF, if it is not 0, the upper half is not 0. I'm talking about the unsigned multiplication. Are you getting it?
Yes, sir.
Okay. So what about the integer multiply? So in this case, so the upper half of the result is, I'm giving more time in this place because we have different examples after this. Okay. So try to get. So if the upper half of, so if I say for I integer multiplication, so what will happen? If the upper half of the result is the sign extension of the lower half, let us say you have a you have let's say FB H and there is your FF. That means what happens here? What is the most significant bit in AL? It is 1, and that one has been extended up to AH. All the values of AH is the sign extension of that one. Or you have the value, let us say 7F. So 7, the most significant bit of this AL is 0. And the upper half is also, let us say this is 007F. So the most significant bit of AL is 0. And this is the extension to AH. So in this case, you know that in both the cases, it is enough that the result will be fitted in AL. It do not need AH. But whenever that is not the sign extension, or that is other than that zeros and ones that is continued from the MSB of AL, then you can say that the product is big to fit in the lower half. Then in that case, it will be 1. Is it clear to you? Or should I discuss a bit more?
Sir, when in the lower half it is AX for 7, the MSB is 0. So
Yes.
so it is extended to 0. Then
Yes.
it's clear. But when it is F, the MSB is 1.
Yes.
How it is sufficient only in the lower half to carry the whole value, because it is
Okay.
not.
Okay. Yes. Yes. Okay. Let me discuss. So you are saying, let us say we have I multiplication for byte, isn't it? For a byte. That means the result will be saved in AX and it is AH and AL, isn't it?
Yes,
Now
sir.
you're saying the result is F, let us say B.
Yes, sir.
Okay. Now, what is the MSB of this one? It is 1, isn't it?
Yes,
Yes,
sir.
sir.
Now, can you tell me what is the decimal of this one in a sign case, because you are using integer multiply? If it is integer multiply, what is the value of this FFFB? Maybe it is -5. Can you check? Can you check and let me know, because I'm having issue. I do not have another window, so I need to go back and again come. Is there anyone who is checking?
-5. It's
Yes,
-5.
-5. Yes. So basically, if it is -5, so what is the representation of -5? This -5 can be represented with 4 bits. This can be represented with 8 bits. This can be represented with sorry, not 8 bits, 16 bits, then 32 bits. But in all the cases, what will happen after this FB? All these values will be 1. If you can remember that the if you just write FFFB, or okay, Okay, can you see, can you see this one? So FFFB, you are saying it is -5. Now in FB it is also -5, but in 16-bit, if you give only FB, then it will, try to see, it will give 251. That means the most significant bit of the 16-bit should be 1 if it is a -5. So that is normally what it happens. That should be extended. Like if you write FF, then it is, you can see it is -5. But if you give 00 FB, then it is 251. But in 8-bit, FB will be sufficient to represent -5. Is it okay? Have you understood up to this? And again, let me show you about 7F. Sorry, 7F. So it is in 8-bit is 127, and in 16-bit, if you have write 7F, so it is 127. So that means in the upper two is basically 00. Are you getting it, or should I explain a bit more? So what I'm trying to say in here is that, so for a number to be negative, the most significant bit should be 1, isn't it?
Yes, sir.
Yes. So in F, only if you write FB, so there are 8 bits here. So the most significant bit is 1. So now you can say this is -5. But in other case, whenever you are going to for 16-bit, now you are writing only FB, that will give you 251, because there are only other two are assumed to be 0. But if you want to represent -5 with 16-bit, then you have to put 2F there. That is the sign extension. Is it clear?
Yes, sir.
Okay. So now let's see one example, then things will be maybe more easier. So let us say we have AX is 1 and BX is FFFF. So first thing first, so if it is signed case, so this is basically equal to, in decimal, 65535, and this is 1. This is unsigned case, and in signed case, AX is 1 and BX is -1, isn't it?
Yes.
Okay. Now tell me, after doing the multiplication of these two, basically we'll be getting this value. So the hex product is this. Now AX is having this and BX is having this. So what will be CF and OF in this case?
0.
0. And in the second case, -1. So it is FFFFFFF. So both of them are having FFFF. So what will be the result in this case?
0.
1.
1.
0, sir.
So why 0?
The upper half is the sign extension of lower half.
Yes, the sign has been extended. The most MSB of this is 1. So that one has been extended up to the DX. So it is basically 0. So if we see the result, 0 and 0. So let's see another example. So okay, let me take the binary from there, 65535. So it is 65535, 65535 for unsigned case, and for signed case, both of them are -1. Is it okay? Now after multiplication, you're having the decimal product is this, and your hex product is this. You're having AX and DX. So what should be the flag?
1.
1. Because basically your upper half is not 0. You need both of them to represent the product. Is it okay? And in this case, -1 and -1, it is 1. So what will be the value in this case?
0.
0.
0, because it is the sign extension, isn't it? Okay, let me ask one specific, someone specific. Okay. 109, are you there? 109. Yes, Salehin.
Yes, sir.
Okay. Uh, can you tell me what will be CF and YF in this case?
So it would be 1 for the first case.
Okay, it should be 1. And for the second case?
It should be 0. Sorry, it should be 1, sir. For the second case.
So can you explain why both of them are 1?
Because the sign has not been extended. It is showing different values for dx.
Okay, then that is for signed or unsigned, or both the cases. Your explanation is valid for, is it valid for signed or unsigned, or both the cases?
That is for sign.
Signed. And for unsigned case, why is it 1?
For unsigned case, sir, I forgot that slide for the unsigned case.
Okay. So basically that means the upper half is not 0. That is the answer, isn't it?
Yes, sir.
Can you remember now?
Yes, sir.
Okay. I'm giving you another example. So we have AX is having this value and A. So now can you tell me what is the what will be the flag status after the instruction?
Sir, for the first case unsigned, it should be 1 because dx is not 0 here.
Yes.
And for imol, it should be 0 because sign has been extended.
Okay. So is there anyone who have not understood up to this, or we have any confusion up to this? Okay, this light is doing so. Okay, so this is the last example. Now you're multiplying 80H and FF. In this case, I want to
Sir, I have a
yes.
question.
Yes.
স্যার আমরা তো হচ্ছে মাল্টিপ্লিকেশনের পরে আনসারটা এইচ আর এল এর মধ্যে পেয়ে যাচ্ছি, এখানে সিএফ আর ওএফ এর কাজটা কি?
Okay, that is a good thing. We are just learning that how the flags are affected, and depending on that those flag you can take decisions. Maybe you can take some decisions, like if you are getting H and AL, and let us say your CF is giving you 0, that means it is enough that you look into only in AL. Are you getting me?
Yes, sir.
So, and the other case you are getting on the result only in AX, you need to go for DX. So that is the thing, you can look into this flag, and there can be other applications also. But one thing you can understand from here is that the result will be fitted into the lower half or not, because you see there are 16-bit and 16-bit register AX and DX. So if we can only look at AX and have the result, then that can be one application, that okay, we know if we just see the flag, then we can say okay, the result is only in AX. Is it okay? So
Yes,
there
sir.
may have other applications, but we're just learning the flag status. Okay.
Okay, sir.
So in this case, okay, 115, are you there? Yeah.
Yes, sir.
You are asking. So can you tell me what is the these two, unsigned case and signed case, is the values?
Sir, I'm not sure.
You're not sure? Do you have the converter, or that's what I'm asking actually?
I don't have it opened.
Okay. So basically, if I'm not wrong, 80H is unsigned case, it is 128. and this is 255 BL. This is BL and this is AL. And in signed case, can anyone check and let me know? That one is -1. For signed case.
Sir, in signed case, 80 will be -128.
And in unsigned case, 80.
So
What is
in
80?
so in 128.
Yes. So in this case, you can see after doing the multiplication, okay, I think there is no problem with the first one. And in the second case, you can see that 128 is the multiplication. After multiplying these two, we'll be getting 128. So it is a positive number, isn't it?
Yes, sir.
Okay. So in hex, it is 8H 00880H. Now, in this case, it is not the sign extension. It is not the sign extension of the MSB. So for that case, basically it becomes 1. But here, one thing is that your 80H is giving you -128 and 128. This is in unsigned case and this is in signed case, isn't it?
Yes, sir.
So basically, whenever you are in signed case, then these two zeros is basically making this 80, that means 0080, it is making it 128. So basically it is not the FF80. For FF, I do not know whether you can just see that if it is FF80, then in that case it should be 128. So it need that one to represent the result. So it is not the sign extension. For this reason, basically this is 1. So this 80H is, if you can remember in flags also, if you can remember that 80H is a different thing because it is both the same number in signed and unsigned cases. So that is the thing that I wanted to share here. Okay. Okay. Then we have a simple application of multiplication and integer multiplication. So one translation of high level language to assembly code has been shown here. So just to show you that how it can be used. So if we want to represent 5a plus 12b minus 12b, so we can use this sequence of codes in this case. Okay. So move ax comma 5, then whenever ax is having 5, and then you are giving the source here. So basically ax will be giving you 5a, and we're assuming that the result will be within ax. So then ax has been moved to a, and that's just simple thing. Then ax 12, and then 12. This is your 12b. This 12b and 5a has been subtracted, and you will be getting 5a minus 12b. Very simple thing. Just one thing has mentioned, that how we can translate the high level language to assembly code. Is it okay?
Yes, sir.
Have you understood up to this? Okay. Then there is another application about the factorial. So you can take 1 minute or 2 minutes. So just try to see what is happening here, and if there is anyone who can explain, then I'll give him chance. Okay. So is there anyone who wants to explain?
34.
Yes,
sir.
34.
So the first line signifies factorial proc. So this PROC means procedure. This initiates the factorial procedure.
Yes.
And later on, sir, they move AX, 1. AX is a register. It holds the value of the product, sir. Now
Yes.
from the next line, top, and in this segment we can see that we have selected MUL CX. Here CX is a register. As we know, sir, MUL operation can select registers or variables, not constant. And then later on, we have seen that there is taken a loop from the top, and this loop will continue until the value of the factorial n is diminished. And later on, the factorial has been ended with endp command. Before that, we take the command read, which is ret, which is return. It will keep on returning to the
34.
top.
34.
Yes, sir.
So can you tell me what does this CX is doing here? And like I'm asking that here you can see we need to decrease the term by 1, and we need to product with the term, and every time this is the equation.
Yes, sir.
Isn't it?
Yes, sir.
So if n is 1, then it is just the product is 1. But
Yes,
if
sir.
n is not 1, then what you need to do? We need to go for the calculation of n, then n minus 1, n minus 2. That
Yes,
means
sir.
every time I need to decrease this term, isn't it?
Yes, sir. Yes, sir.
Decrease this term and multiply with the product.
Yes, sir.
That will give us the factorial. But how it is happening here? You are only multiplying, isn't it?
So this is happening through the loop term, sir. As long as, sir, if n is greater than 1, it will take on coming. It will keep on coming back to the multiplication CX and initiate the operation again.
That means you are saying the CX will be decreasing, isn't it?
Yes, sir.
So this loop will run up to the CX becoming 0.
Yes, sir.
So whenever CX will be 0, this loop will broken, and that will come back. So basically that is the thing. This CX is basically your term, and also this is your counter.
Yes, sir. Counter.
Yes, it is also counter of the loop, and also it is your input. So our product is initially set as 1, then every time it is multiplied with the CX, because AX is a, but in these cases, try to see, we are assuming that the result will be enough to store in AX.
Yes, sir.
Okay, 34. Now we'll be moving to division. So there is unsigned division and integer division, and the similar thing that your div and idiv. So in this case, the similar cases is here. I will explain that thing. But what the dividend can be 16 bits or 32 bits. But we can divide it. Okay, if you can, we can divide this 16 bit with 8 bits, and this one with 16 bit, and the result and remainder, there will be result and remainder. So all of them are 8 bits. Oh, sorry, in this case 16 and 16. That means your dividend, the thing that you will be dividing, it can be 16 or 32 bits, and other things like the divisor, the remainder, and quotients, all of them should be of same size. Is it okay? So we'll see how to in case of multiplication, we had AL and AX. Sorry, AX, AL and AX. We were assuming that one of the operands will be one of the number that we want to multiply, that should be in AL or AX. In this case also, we expect that. So try to get this side is basically is a byte form, similar thing, byte form. This dividend we are talking about, this is before the instruction executes, and after the execution, the result will be result that will be getting, that will be quotient, or it will be remainder. So I have said that the divisor and these two will be same size, 8-bit and 8-bit, and in case of byte form, our dividend will be 16-bit. So whenever we'll be using, you can see it is same thing, div source, idiv source, so signed and unsigned case. Whenever we'll be writing this particular instruction, then it will assume that our dividend, the things that we want to, this is basically your divisor basically. So ax will be divided by the source, and the result will be in al, and ah will be having the remainder. Is it okay up to now?
Yes, sir.
Okay, so the same thing, similar thing in word form. So the dividend, we assume that it should be in dx. So dx ax, if I write div a word, that means let us say bx, so it will be divided by bx, the whole thing, that means 32 bits. So dx is your most significant 16 bits, and this is your least significant 16 bits. If your dividend is something bigger than 16 bit, that we can store up to 32 bits. Okay, so after dividing, the result will be in ax, and dx will be having the remainder. Is it okay? Just try to remember that. Okay, if I just go back, ax will be divided by the source, and the result will be in al, and the remainder will be in ah. And in this case, that means try to see the lower half will be having the result, and the upper half will be having will have the remainder basically. So if we say, so in this case, dividend will be in dx and ax, and after division, after running the instruction, I have said that this part is before the instruction runs, and after the instruction, the results will be in ax and dx. So ax will be having the result, and dx will be having the remainder. Is it okay up to now? Just similar thing.
Yes, sir.
Now in this case, basically, uh, in this case, there can be two ways that the divide overflow can occur. So the divisor can be is smaller than the dividend, like much smaller. In that case, if you just what should I say, if you divide, uh, let's say in idiv, that means you're multiplying uh, this division, and you are dividing 255, that means sorry, you're dividing 120. Okay, okay, we'll be having the example. I should go for the exact example so that you can understand. But thing is that if it is much smaller, then it cannot be fitted. It is difficult to fit in the destination. That means we have the destination al and ax. So the result will be in either al. In this case, the remainder will be in ah, and in this case, the remainder will be in dx. So the result will be of 8-bit or 16-bit. So if it exists, if it goes beyond that limit, then the divide overflow will be there, and the program will terminate. So we'll see a few examples after this. So here, what happens? Okay. Sorry. So in this particular case, your dx and ax, that means in total you have 00005, isn't it? So dx ax, if I represent that in decimal, it is basically 5d, isn't it? Is there who can respond? 134. Yes, 134. Yes. I'm saying that if you are having 5h, that means in decimal there is 5, isn't it? Yes, and bx is 2. That means also it is in decimal, it is 2. So I'm just giving the example so that you can understand, because we are familiar with the division of we are familiar with the division in basically decimal. So 5 divided by 2, what will be the result? 2, and remainder will be 1. There is no point thing here. The remainder and the quotient, that will give you the result. So if we divide 5 by 2, then 5, okay, divided by 2, it will give you 2, and remainder will be 1. Is it okay?
Yes, sir.
So if you go back to your uh, childhood, you can remember this is 4 and this is 1. Are you familiar with this syntax?
Yes, sir.
Yes. So in case of signed case, in case of unsigned version, you can say div bx, then your result is 2 and remainder is 1. Then who should keep whose value? So we have said before that ax will be having the result and dx will be having the remainder. Is it okay? So in both the cases, basically they will be same because there is no sign number here. So both the results are same. Both divisor and divisor are basically positive. As both of them are positive, they will be giving the same result. Okay, let me go to the another example. So basically dx and ax is giving you 5, and bx in unsigned case it will give you how much? FFFE. Yes, -2 in signed case. And what is in unsigned case? 65534. Thank you. So in this case, now you are dividing 5 with, let us say, in this is your unsigned case and this is your signed case, isn't it? So you are dividing 5 with 65534. So what will be the result? You cannot actually, even if you give 1, it will not work. That means it will be 0, and it will be 0 and remainder will be 5, isn't it? The same thing happened here. Your result is 0 in unsigned case, your remainder is 5, and the remainder is saved in, this is your remainder, and this is your result. So it is 0 and this is 5. But in case of unsigned case, in the unsigned case, what happens? You're dividing 5 with -2. That means if we have -2, then -2 -2 4, remainder will be 1. So try to see, your remainder is 1 and the result is -2, which is FFFE. Is it clear? Is there any confusion up to this? Actually, we are having a very simple multiplication and division things. So at the end, basically we'll see one example. At the time you can see that why we need these things in assembly, and one of the applications, obviously. Now in this case we have a divide overflow, so we can see in this case. Now this FFFF is 65535, I think, in unsigned case, and in signed case it is -1. And this is B, that means it is what is the unsigned number in this case? Maybe in signed number it is -5, but what is the unsigned number? Okay, or 0. That means in this case, okay, I'm Sorry. Basically, we're having the divided into dx and ax together, isn't it? So if the number is f, and after that f, and after that b, so it will be a huge number in unsigned case, isn't it? So if we just divide that in by 2, that will not fit in ax basically. Are you getting it? So it is a 32 bit and most of them are 1. So if we divide that by 2, that will not fit in 16 bit. So that's why for unsigned case it is showing divide overflow. Are you getting it?
Yes, sir.
Yes. But in unsigned case, you can see this is just this. In the signed case, it is just the sign extension. Even this number is representing basically -5. So the answer again goes to there, that for 8 bit, for 16 bit, and for 32 bit even, you need to extend the sign. So it is -5 basically. So if your division is -5 and you want to divide by 2, that means what happens? You give -2, then -4, and then your result will be -1. So you can see -2, -1. So -2 will be saved in ax, and this is the remainder. Is it okay? Are you getting it?
Yes, sir.
Okay. So similar thing in this case, basically your idiv is getting is getting divide overflow. So you can just see why in this case. So okay, let me. Okay, 92, Sakib, are you there? 92. 92. Then 138, Sakib. Sakib, are you there? 138. Okay, let me put it open to all. So is there anyone who wants to explain just why it is getting overflow? Anyone? '88.
Sir, wait, I'm thinking.
Can you explain this part? Yes, 134. 134. Yes. Okay, what is FB? Your answer is basically obviously that's why it is having divide overflow. But if you want to explain why, then you need to know
So can I
this
say,
value.
sir?
Yes.
Sir,
So can I answer?
Yes, 115.
Yes, sir. Sir, in the sign case, if we divide these two, there will be a negative number. So there will be 2f before the 8 bit. So that will be a 16-bit answer, but our AX is only 8 bit, so it will overflow.
Okay, I have written something on here. Sorry, just a minute. So yeah, your Result will be in AL, isn't it? And okay, I'm getting confused actually. Let me just go back. AX. Sorry. So basically, this should be AH, isn't it? Because the result will be in AL and it is AH because it is a byte multiplication.
Yes, sir.
Yeah, byte division. So AX is having the dividend. So it is basically 251. Okay. So in the first case, it is 251 and it is maybe 255 if I'm not wrong. So you are dividing basically 251 255. Basically it will give 0 and 0 251. So it is for unsigned case. Is it clear? So 0 and this is 251. On 15.
Yes, sir.
Yes, yes. Now again in another case, what happens? Basically you are dividing 251 with basically -1. Then what happens? So basically if you see, it is basically 251, then it will give 251, that will give 0, but -251, can it be accommodated in AH?
No, sir.
Because the maximum negative number you can have is 127 maybe and 128. So this is the range for 8-bit, if you can remember. So that's why the divide overflow occurs here. So the result is 251, but it cannot be fitted in AH. Is it clear up to now?
Yes, sir.
Okay. Then here just these 4 slides are basically sign extension. So thing is that in case of word division, the dividend in the word division will be saved in DX and AX. DX should be prepared even if the dividend fits in AX. That means you need to clear DX. Let us say your AX is having 01008. It doesn't need DX, but even after that you need to clear that one. So for the unsigned case, it should be cleared. For signed case, the sign should be extended. So if it is say FF06, let us say, so this sign should be extended. That means all of the DX should be FFFF. But if it is 7F06, then all the as the MSB of AX is your is 0, so that should be extended in DX. That's what he's saying. So in case of unsigned case, DX should be cleared. But in case of signed case, the sign extension, that means the MSB of AX should be extended to I. So in which case? It is the case where your dividend will be fit into AX. Is it clear to you? So we have this instruction CWD, convert word to double word, will do the extension. So here is the example. Let us say you have 1250. So you want to divide that using 7. So what you need to do after writing move comma AX, as you are having minus and also if it can be plus, so this sign should be extended to DX if you want to use IDIV. Is it clear to you? So
Yes.
if you wanted to use this div, then you need to XOR dx comma dx, so that dx will be clear. I'm not getting any response. Is it clear to you?
Yes, sir.
Okay. So the same thing for the byte division. So for a, even if your age will be the dividend, okay, will be in ax. So even if it is fitted in al, but a should be cleared in case of unsigned, and in case of signed, the sign should be extended to ah. Okay, so cbw convert byte to what will do the extension. If you want to use idif, then you need to use that cwb or cdw. So if you want to use this particular thing, okay, there is this part of sign extension. Now the last part of today's lab is basically try to just I'm going through I'm just looking at mm, I'm just reading out. The computer represents everything in binary. The input output expressed in decimal is convenient for the user basically. So a procedure may be written to handle decimal input and output. So it is written in the both out deck and in deck for input and output of decimal. So this will be discussed here, and the input part you will see by yourself. It is your home task. So basically it is convenient for us to give any input in decimal and to see the output in decimal, isn't it?
Yes, sir.
So basically for this particular reason we want to have this two thing. Okay, now try to understand what is it what does it saying. Okay, I'm giving you 1 to 1.5 minutes, so you can just go through. So thing is that if we want a decimal output, okay, so this decimal number can be positive or it can be negative. Can you hear me?
Yes, sir.
Yes. So it can be positive and negative. So basically at the beginning, we'll check whether this number is positive or this number is negative. So if it is positive, then we will directly go to print the content in decimal. So whatever the content in hex, we'll try to, or in binary, we'll try to convert that to decimal and we'll show that to the display. But if the number is negative, then what we'll do, we'll print a minus sign at the beginning. So let us say it is FFFB. That means it is -5. So whenever we'll be having this one, and then this minus sign will be printed. Whenever it is less than 0, then minus sign will be printed to the output. And after that, we'll replace this. Let us say it is in AX. So we'll replace this AX with minus AX. So what will happen in that case? This will be converted to 0005H, isn't it?
Yes, sir.
Yes. So basically, if we want to print only 5 or -5 in both the cases, we just need, after checking this, we just have this thing to do. Just print the decimal equivalent of the positive binary number. So even the number is negative, after doing the this negative operation, basically we have 5, this 5 to print, and if we have this one, then this 5 to print. So after checking and printing that negative or without, if it is a positive number, the thing that we need to do is print the decimal equivalent of the positive number, positive binary number. Is it okay? So how can we do that thing? So I can show you here just one example. Let us say you have 2461. So how can we print? How can we have? What is the idea that we can print this one in your by the assembly language? So before that one, if we divide this by 10, what will happen? What will be the result and what will be the remainder? What will be the question? Anyone?
246.
246, and the remainder will be
1.
1. Same thing. Now if we divide this 246 by 10, so what will be the result? 24, and remainder will be
1.
6.
Sorry, 6.
Yes. Then 24 by 10, then how much? 2 and 4. Then same thing, 2 by 10, then remainder will be 2. That means you are getting, try to see, you are getting the same thing, 2461 in the remainder, in the reverse direction, isn't it? So now if I push, if I do a stack operation, if I push this one at the, if this is your stack, so if I push after every operation, if I push, then 1 will be here, 6 will be here, yes, then 4, then 2, isn't it? Whenever I will pop, then during the push I'm giving like this, and whenever I will pop, what will be the result? 2, 4, then 6, 1. That means we will be having this 2, 4, 6, 1 after every pop operation, and that can be converted to ASCII, corresponding ASCII of 2, and we can print. That's the idea. Is it clear? How we'll do that thing?
Yes, sir.
So if I say the whole procedure again, just without going to the code, then first we'll check whether it is positive number or negative number. If it is positive, then we'll directly go for doing this particular operation. That means dividing by 10, then having the remainder. And if we have a negative number, then after checking, then we'll print a minus sign, and after that we'll do this neg operation, and after doing the neg operation we'll be having a positive binary number to be printed. So then after that we'll come here. So after coming here we'll after doing all this operation, then we'll, after every time we'll push it, then after popping we just after do the pop operation, we convert this 2461 to the corresponding ASCII, because if this is if we want to print, then every time we need to make that in ASCII value. So the corresponding ASCII value, then after that we'll just print that one by one. So here's the just written the pseudo code, you can say, or the algorithm. So if it is less than 0, then print a minus sign and replace a by 2's complement in diff, and then get the digits in AX decimal representation. Okay, so you can see we'll count how many remainder will be there. Then every time we'll divide the quotient by 10 and push the remainder in the stack, and we'll count that thing up to how much? Up to the quotient becoming 0. So the second part is converting to digit to character. That means or for loop should be there, pop a digit from the stack, then convert it to character, output the character. That's it. So in this case, now I'll just explain just the parts. So here you can see we're writing a procedure, and you can see push ax, bx, cx, dx. This is a good practice. I have said during whenever we have discussed the procedure, because all these values will be can be altered, and at the end you can see they have been popped to dx, cx, bx, and ax in the reverse direction to restore the registers, because in between those values will be changed, but maybe from the main procedure you are calling this outtake. At that time ax, bx, cx having some important values, that those can be overwritten in these cases. So okay, why are we using this or? So if you can remember, this or basically affect your sign flag, then zero flag, parity flag, all those flags. So basically when we will be doing or, so if you're basically you're checking the number, whether that is less than zero or greater than zero, all those things. So this is a signed, I should say, jump. So if your MSB is having 1, in that case it will say okay, it is less than 0. So other than this, so it will be greater or equal to 0. So if it is less than 0, if it is greater than or equal to 0, it will jump directly to bypass this negatives, making negative. But if this does not fulfill the condition greater or equal, that means your number is negative, so it will come to here. So we're pushing AX to save it, then printing the negative sign, and then popping AX and doing the negative of AX. So that is the idea, and try to see your input is basically in AX where we want that. So after this line, basically, and after jumping here in the next line, basically we want to print from here. Basically we want to print the positive binary to the character, and maybe this part you have done maybe in lab number 4 or 5 if I can remember. So in that part you can remember that how to show the numbers. Okay, so even after that cx is your counter, and bx is having 10d, that means the divisor. So where high bytes of the divider, try to remember you are using div. So we are uh, clearing dx, so div bx, that means we are dividing by 10, that means dx ax is being divided with bx. So ax is having our input, and dx we have cleared it, making 0 0 0 0. So after having the result, so after doing the what should I say, after doing the operation, ax will be having the result and dx will having the remainder. So we'll push this dx in the stack and we'll increase cx, so to count the number of remainder. So and we'll check whether ax has got to 0 or not. If you can remember this jne, this is a flag jump, and you can say this is equivalent to jump node 0. So these two are same. So if ax is not 0, then it will again jump here and it will come back again jump. So whenever it will be 0, it will go for printing that particular value. So in that case again we'll be having a loop here. So in this loop this loop will see the value in cx, because we have increased cx. So it will run to the value of cx. We pop dx. If you can remember how we are pushing and how we are popping, because they should be in reverse direction. So that's it. Now one thing I want to mention here, so is there anyone who can explain this line, how we are converting this particular, let us say we want to print 2, that means we are having 0 0 0 2 h. Now we want to print this one. So why we need to do, how we are doing this conversion from this number to character? Anyone?
So from the ASCII value.
Yes, from the ASCII value. Can you be more specific? Like, Yes, we need to add. So in the last class, maybe your Arif sir was saying that it is more efficient. It will be more efficient if we use bitwise operation like AND or to do different operation. So you already know how to add those things and how to add 30 and print. But I'm asking using OR the DL comma 30H, we can also convert the number to character. So how it is doing that particular operation?
So OR is basically addition.
Yes, in a sense, you can say that for this case, uh, because you can see for 2, basically it is 32H, isn't it?
Yes, sir.
So whenever you are doing OR with let us say only two, let us say it is, let me take 8-bit. So you're taking 02 comma 30. So if we OR, then it will give 32H. If we go in again in maybe if I can remember, your 30H is something like this, and this is your 30H. Sorry. So if this is a 30H, then your numbers from 0 to 9, so your maximum number 9, what is that? It is 1001. That will not affect this one. So basically all these 0 to 9 will be affecting this last 4-bit. So if we just OR with 30, so but why we cannot tell directly add, because so if you may have a number, okay, 00 let us say 10, so in that case you're losing this bit, like if we add these two and OR these two, they may not be the same. Is it okay? 88.
Yes,
Are
sir.
you getting it? Yes. If they are added, they may not be same. But okay, in some cases, okay, the addition and OR are similar thing. Okay, basically that's that was our things today. So if you have any question up to now, we can go on, and I have some announcement to do. So first of all, you can I will take the attendance, and by this time try to see whether you have any confusion or anything to ask regarding this lab or not. Okay, let me take the attendance first. Okay, 35, 16
Yes,
batch,
sir.
35, 16 batch. So, you know that you will be you'll be given one. We have said that that can be a presentation or project, and you'll be having written test and also viva. So all these things we plan to do something. So 93, are you there? So just
Yes,
keep
sir.
yourself unmuted, because how many labs do you have in third year? Like we have 4602 and 4616, and what are the others? Maybe Saad is not taking the hardware lab.
Yes, sir. Control system ল্যাবটা হচ্ছে স্যার, আর স্যার অপশনাল কোর্স স্যার উইথ ল্যাব গুলো স্যার হচ্ছে স্যার, মোট
তার
5টা
মানে
ল্যাব।
মোট 5টা তো হচ্ছে না, এখানে 2টা ওখানে 2টা।
ইয়েস স্যার,
হ্যাঁ,
মোট 4টা
তো
স্যার।
4টা ল্যাব। আচ্ছা, এর মধ্যে 2টা তো আমরাই আমি ইনভলভ। ওকে, নাও thing is that the last class that we'll be you'll be having in the next week, that is important to select the topics on which you'll be giving the presentation. Is it okay?
ইয়েস
So
স্যার।
we'll discuss that thing in the next class also, and also yes, in the next class. But by this time, okay, let me tell you about the tentative dates. Okay, so this is December 8, then 15, on 15 you'll be having another another class, and 18 December, that is a Friday. So that will be the last date to make your groups and also selecting the topics. 18th of December. And after that, you'll be giving your presentation on during the class time, obviously during this period, on 29th and 30th of December. 29th, and you will be getting more than 1 week and almost 10 days to get prepared. And after that, you will be having Viva on 5th and 6th. That means for you only 5th of January. But we want that you attend the written quiz in between these 2 dates. That means from 31st of December to 4th of January. Is it okay
Okay.
for you?
Yes, sir, it's okay.
So you can choose a date for the written, but for Viva and presentation, we want to keep the class time. So you do so that you will not have you need to arrange and other times. Okay.
Yes, sir.
So in 15th you will be having class, but in the 22nd of December, maybe you can have we can have a week off, and then you'll be having those things. Now, keeping this in mind, you can also select the date for 4602. Okay, Sadman.
Yes, sir. Yes, sir.
Just I want to, because the next lab is not that much tough. And another thing is that for 4602, Dr. Ruelman sir is not has not covered the Fourier's transform yet. But what I have seen in the syllabus, maybe it will be difficult that after finishing Fourier transform, maybe those will be in the last classes. So I want to cover the topics that is needed for the lab. During the lab, I want to finish the lab. Okay.
Yes, sir. Yes, sir.
So 75 minutes will be enough for each of the groups. So I will request you to discuss with other CRs and
Yes, sir.
try to arrange all the labs in the next week.
Yes,
A1,
sir.
A2, B1, B2, but I want them in separate times. Okay.
Okay, sir.
But I think it will be enough to have 1.5 hour. That is more than enough. Then 1 hour and 15 minutes if you are present in due time. So you can keep 1.5 hour or a bit less or more than that. Is it okay? Now about the group formation, maybe we have discussed, we have not yet decided, but it can be a group of 3 basically. So if you are 30 in a group, maybe 10 groups in a single
Sir,
section. Yes.
স্যার 4 জনের গ্রুপ হলে মনে হয় স্যার ভালো হয় স্যার। আমাদের স্যার 27 28 জনের মতো থাকে স্যার প্রত্যেকটা ল্যাবে স্যার নরমালি।
28 জনের মতো থাকে।
ইয়েস স্যার।
Okay. Okay, about the number, I actually Arif is a bit busy today. He went to the hospital, but let me talk to your Arif sir first. Then we will select the number. So if it is 3, then yeah, even after if you are 28, there is no problem with that. So
Yes, sir.
into 9, it is 27, isn't it?
Yes, sir.
So one can be added to any of the groups. So one group can be of 4 groups. But thing is that I want actually you, and also I will say the CRs also, to make the groups and send me the Excel file. But I'll let you know about the numbers just maybe within 10 to 15 minutes. Is it okay?
Yes, sir.
And about the topics, maybe I'll give some of the hint maybe in the Google Classroom, and also if it is not given, so maybe in the next class we'll discuss about the topics.
Yes, sir.
Okay. And if Arif is available by this time, maybe we'll discuss in other sections, and a written form will be given in the Google Classroom. Okay.
Okay, sir. Okay, sir.
Okay, thank you everyone for being here.
Okay, sir. Thank you.
Yeah. Assalamu alaikum.